Hello biologists, here is a little bit more practice working with osmosis. It's a little bit more advanced practice, but it will be similar to something you may see in the future on an assessment. And so here I have 5 beakers, and in each beaker there is a cell, and I have the molarity on each of those. Now, the one thing you do need to understand is that molarity, so M, is basically telling you percent solute. So let me redo that a little bit just so you guys can see it a little better. My pen would work. That would be awesome. There we go. Okay, so the M equals percent solute. So this is not water, this is solute. This is the particles inside. And so the bigger M, the more concentrated the solution. And so the first thing that it asks you to do is to label each solution as hypotonic, isotonic, or hypertonic. And how you figure that out is you simply look at, is there more solute, hyper, or is there less solute, hypo, or is it equal solute? And so it really is just comparing numbers. And so you can see that in A, we have 0.2 is less than 0.6. And so in this case, the solution would be more, so it would be hypertonic, because if we remember, hyper is more, hypo is less, and iso is equal. Okay? And that's talking about solute. All right. So if we look at container B, we have inside we have 0.2 molar, outside we have 1.0, and so 2 is significantly less, so it's going to be hypertonic. In C, we have 0.2 and 0.2 in the solution, and so these are equal. If I go to my chart up here, I know equal is isotonic. If I go to D, inside is 1.0, outside is 0.2, and so now the inside is more than the outside, and so the outside solution is what we're referencing is less, so it would be hypotonic. And then the last one, we have 0.2, 0.4, 0.2 is less, so less on the inside, that would be more on the outside. So the solution is what we always want to use. The solution has more because 0.4 is more than 0.2, and so this is hypertonic. All right, so now we have all of the solutions labeled in relationship to the cell. Now we can determine how is water going to move. So the next part is using an arrow, show the direction the water will be moving. All right, so I'm going to go ahead and get some arrows here. So in the first one, because it is in a hypertonic solution, water will come out of the cell. And so water will be moving out of the cell in order to dilute the hypertonic solution, because there's more water in a 0.2 molarity than there is in a 0.6 molarity, because that is the solute. All right, in the next one, we have water will also be moving out because it is also hypertonic. And a matter of fact, there's going to be even more water moving out here because there's a larger difference. In C is something different because it's isotonic, so it's the same. And so a lot of kids will want to say, oh, water's not moving. That's not true because water's always moving. And so for C, what you want to show is that water is going to be moving in and out. Water will be moving in both directions equally. All right, if we look at D, D is the only one that's in a hypotonic solution. So it's in a solution that has less solute than inside the cell. And if there's less solute, that means there's more water. So it'd be 0.8 of water. And so for this one, water will not move out. The water will actually move in to the cell in order to try to dilute. And so this cell will get larger. It will gain mass. All right. And then for E, we have a hypertonic solution. Water will always leave the cell into a hypertonic solution, and so water is going to move out. So now I have the second part. I've shown you that direction that water is going to move in order to reach equilibrium. Finally, list the solutions or cells, so A, B, C, D, and E, in order from greatest increase in volume of the cell to greatest decrease. Okay, here we have to do a little bit of math. And so what we're going to do is we're going to look at these numbers. What's the difference in the solute? That's going to determine the tonicity. So it's going to determine how strong that osmotic pressure is. And so in here, the difference is going to be 0.4. So water's going to be moving out. And so it's going to be about a 0.4, okay? That's the difference. On this one, you have a 0.8. Well, 0.8 is going to be bigger than 0.4. And because of that, it's going to require more water to leave. And so B is going to lose more water because it has a bigger difference in the molarity and the concentration of the two solutions. For C, you have 0, and so there's not a concentration gradient here. They're going to be equal. They're going to move back and forth evenly. There will be no mass change. So there is no change in mass or in volume. Okay. If we go to this one's actually going to gain mass. So this is the first one. So we're going to lose here. We're going to lose mass. This one we're going to lose mass. This one is the first one we're going to gain mass. And the difference here is 0.8 again, but we're going in the opposite direction. So this one's actually going to be my greatest mass. This one's going to be the one that has the greatest amount of mass at the end. And then the last one, 0.2 to 0.4, that's only a difference of 0.2. It's going to lose mass, so we're going to go down 0.2. So now I can put these in a sequence. And I want the sequence from the greatest increase in volume. Okay, so my greatest increase in volume, if I write these out, let's do, I'll put them in red here. If I have the greatest increase in volume, my greatest increase in volume is going to be D, because it's going to gain, and it's a difference of 0.8. The next one, if I'm going from greatest increase to greatest decrease, would be C, because C is not going to change at all. And the other three are all going to change volume. Now I look at the numbers. 0.2 is the smallest number, therefore it will have the least amount of decrease in mass. So the next one would be E. 0.4 is next, and so that one will have, A will have the next amount, and the solution cell combination that will lose the greatest amount of volume and the greatest amount of mass will be B, because it is in the most hypertonic solution, or the solution with the greatest difference in its concentration. And so the greatest amount of water will have to move out in order to dilute the strongest solution. And so here would be the correct sequence. We would have D, C, E, A, and B would be the smallest. Hope this helps. Stay safe.